In this example, we're asked to show that the following statements are equivalent. So there are many ways to do this. One way is to introduce, so because these are statements about compound things involving the variable x, the number x in this case, one way to do this is to introduce in this case this would be if we number these 1, 2, 3, we can introduce a fourth statement here which says that x is even. Now you can't just make this up, right? But we already know that this one is true, that x is even if and only if x squared is even. So I'm going to leave that one, if you don't believe that one, I'm going to leave that as an exercise for you guys. So these two are equivalent to each other. And now what we can do is use, so what I will prove here is that these statements are equivalent to x is even, and we'll see how that goes, okay? So this 3 is biconditionally equivalent to 4. That is left as an exercise for you. But let's do 1 implies 4 and 4 implies 1. So let's start with 4 implies 1 here. So these are all the different cases that we need to prove. If we want to prove these are all equivalent to each other, they're going to all be biconditionally equivalent to number 4 here, to this x is even. So for this one, what do we do? Well, we say let x be even. Then there exists, right? There exists a k. So there exists a number k. It's an integer here. So an integer k such that, what's true? Well, x is equal to 2 times k. All right? And then so we're going to kind of do two things here. So once we know that x is even, let's imply 1 and 2. Alright, so we'll kind of take care of two things at once here. So two things. So first of all, then 3x plus 2 is equal to 3 times 2k plus 2, which is equal to 2 times 3k plus 2, which is 2 times 3k plus 1. And of course, we have to say that this 3k plus 1 is an integer. We can use a symbol here. So we conclude then, thus 3x plus 2 is even. And so now we've got 4 implies 1. All right, 4 implies 1. Similarly, we can plug this into number 2, right? So similarly, x plus 5 is equal to 2k plus 5, which is equal to 2k plus 4 plus 1. Break up the 5 to get the 1 out, right? And then this is equal to 2 times k plus 2 plus 1, where, of course, k plus 2 is an integer. And what do we conclude here? Well, we conclude that x plus 5 is going to be odd, right? So thus, x plus 5 is odd. All right, so those are the proofs of 4 implies 1 and 4 implies 2. Very straightforward. For the other two, how are we going to do these? So we want 1 implies 4 and 2 implies 4. Those ones are going to be best done by contraposition. So contraposition. And so this one we're going to do, so 1 and 2. These are separate proofs, but I'm writing it this way because it's how I'm grouping the proof together. So for these to imply 4, these are going to be done by contraposition. So for this one, we're going to assume that x is actually odd. So let x be odd. And then there is an integer, so an integer k, such that x is equal to 2k plus 1 now. And now we just repeat the same arguments, right? So then 3x plus 2 is now equal to 3 times 2k plus 1 plus 2. And we just work this out, right? So this becomes 6k plus 5. And like we did before, we just take out the 1 from this, and we can write this as 2 times 3k plus 2 plus 1. And then we'll just state here, whence 3x plus 2 is odd. All right, so that by contraposition, this tells us that if, so this is contraposition, then if 3x plus 2 is even, Then what's got to be true about x? Well, x is even. Okay. So one more, same deal here, right? Now let's say the other one is x plus 5. X plus 5 is now going to be equal to 2k plus 1 plus 5. Well, that's 2k plus 6, or 2 times k plus 3. And we use this funny word whence, which you can use this all the time in math proofs, but probably never in real life, right? But this means that x plus 5 is even, right? And again, by contraposition, this time we have shown what? This time by contraposition, what's true? If x plus 5 is, in this case, odd, contraposition, right, is odd, then x is even. All right, and so we have now shown these two green biconditionals up here, that 1 is equivalent to 4, 2 is equivalent to 4. Right? That means then that 1 and 2 are equivalent to each other. They're mutually equivalent because you can get from 1 to 2 by going through 4, and 2 to 4 by getting 2 to 1 by going through 4 as well. Now, again, I'm leaving this biconditional for you guys to do. This should be known to us, right? We should have already done this, but if not, take some time and prove that these two are equivalent, and at that point we can conclude that all three of these are mutually equivalent to each other. So this one is done by kind of introducing another statement which is mutually equivalent to all three of these, and therefore these must be equivalent to each other. It's not the only way to do this. You could just directly work with these three statements and prove that they are equivalent to each other. But this is just one example of one way that you can prove that multiple statements are equivalent to one another.